Rabosky.
I'd like to first say thank you for inviting me to this particular seminar. It's my first time here. I have presented as the last speaker at seminars previously, and this is the most people that I've ever seen. So thank you for being kind enough and interested enough for being here. The first thing that I would like to do is thank my funding sources for this particular talk on photons. It is actually from the National Institute for Technology Presentations and Information on Communication, or otherwise known as NITPIC, as the Extreme Project for Infinite Collaboration, or EPIC. And so our friend the photon, I actually am very friendly with photons as I study solar energy. And so I'll start with today, what is a photon? How can we photons help humanity? In this case, we can see, actually through The Simpsons, how this has helped humanity through laser hair removal. So what is a photon? We have this conundrum in physics. Is it a particle? Is it a wave? I actually don't know. Quantum mechanics told me the answer previously. I had it in field theory. I think it's both, but it depends on the spherical cat that we had the question on earlier. Is it dead or is it alive? As you can see through these pictures, which are very clearly ambiguous, and I also need a very large stick because I'm very short, we can clearly display that we have both a particle, which we always show as a circle, or as a wave, or in this case kind of wave-like because it actually is not symmetric all the way through and the periodicity changes. Notice that the color in these pictures changes as well, and this tells us something about the photons and the energies and the wavelengths of those photons. Through space, we know that photons travel over incredibly large distances, and they do it really fast, which is incredible. I really wish my car could do that. The cosmological redshift helps explain the universe. Obviously, it also helps explain how I can get out of my next parking ticket by arguing with the police with the Doppler shift. So, or I should say speeding ticket. But, you know, photons from the sun, they don't travel as far as something like a pulsar at the edge of our universe. But what they can do, and this is partially great for me, is they can give us free energy. Energy that many of us are using in our homes today. And also penguins with balloons. Who knew? So let's go back to the laser. You can see that photons can be very helpful on a very limited range, as we just saw with the laser pointer method, depending on how well the laser pointer works. We also have lightsabers, which in this time frame is incredibly applicable to the fact that Star Wars just released their last trailer. I highly do not suggest going home and trying laser hair removal on your own. This should be done by professionals only. By professionals, John Armstrong is one of them, and I hear that he is doing this after work today.
Experiment.
If anybody needs some laser hair removal, done. In the next century, we will have a red-hot knife that can actually slice through bread with getting no crumbs in your butter. And this is going to be the next exploration of photon energy and usefulness for our science. All right, so let's talk about photons. Other uses. We have solar energy where we actually create electricity from them. But in all cases, we don't necessarily need to use this at our home. We may want to use this in our evening hours. Physics is all about kinematics, and kinematics is how we play pool. Why can't we do this with modern physics? Photons and the wave-particle duality are one of the clutch ideas from our modern physics course. And now with the laser-guided pool cue, we can actually bring modern physics to our pool table, which has been described through classical mechanics up until this point. We come back to our cat idea. The Schrödinger uncertainty principle tells us that we don't really know. If we know the momentum, we can't know the position. If we know the position, we can't know the momentum. However, what we do know is that if you have a cat and a laser pointer, the cat will chase that dot, even though it does not know its position or its momentum. So with that, I would like to take any questions.
Time for a couple quick questions. I'm a cubic cat.
If you were to shine lasers on that, similar to how you would I'm assuming that falls a spherical cat as well.
Yes.
If you were to fire enough lasers at that cubic cat, where would it go?
It would explode, obviously. That amount of energy from the photons has to go somewhere. And the cat cannot contain that amount of energy, and it would explode in happiness being able to chase that laser pointer, or many laser pointers around the room.
How can you possibly explain cats that don't chase laser pointers?
Well, and this is one of the special case incidences that we don't like to talk about in physics. This is where we have an exception to the rule, and this is outside the scope of that talk.